in order to be really successful with trigonometric ratios and understand them, you need to be able to apply them to problem situations where you may not necessarily have the drawing already provided for you. And so what I'm going to try to do in this tutorial is just to provide some guidance on how to set up some of these problems. So you're flying a kite with 20 feet of string extended. So you have string extended to a kite, and it says the angle of elevation from the spool of string to the kite is 41 degrees. So you may be holding the spool here, and then your angle of elevation, which is going to be in reference to the ground here, is 41 degrees. So let's get in here, 41 degrees. Okay, remember your angle of elevation is always with reference to the horizontal. And so if we were trying to find the height of this kite, we know that that's going to be straight up and down here. So what other values do we have? We have that the kite string is let out at 20 feet of length. And we want to know how high the kite is flying if you're holding the spool 5 feet off the ground. So be aware that this triangle in this problem situation is going to be an additional 5 feet off the ground, and so we will need to add on 5 feet to the side of the triangle where we're looking for the height of that kite above the spool. On part B, you want to hang a banner that's 29 feet tall from the 3rd floor of your school. So you're going to try and take this banner and put it on the wall here, but you need to know how tall the wall is, and there's a large hedge in the way. So this hedge here is keeping you from measuring how tall this is. And so you're going to throw a 38-foot rope out of the window to your friend, and she extends it to the end and measures the angle of elevation here to be 70 degrees. And so from this rope here up to that window, there's an angle of elevation of 72 degrees. Now we will look for how high the window is. So we've thrown out 38 foot of rope, extended it straight, so that's going to be the hypotenuse of the triangle. And once you look at the height of that wall there, we know that this hedge is 6 foot, and so we can take that away and see how much space we have here, and see if we really do have enough room for my 29 foot tall banner. Alright, let's look down here at part C. 450 foot tall building is 386 feet away from a shorter building, so straight line distance here, that's going to be 386. You can also see it down here, so either place you could place 386, and so you've got different triangles you could potentially work with. There is a triangle down here that you could work with if you knew the angle in the corner. You could also work with this triangle, seeing that it has 35 degrees, and this would be an equivalent height on this side to find that shorter building. Or you could use this top triangle with 25 degrees and take 450 and subtract off that piece. On part D, some important things to note. You are watching the fireworks display from where you're standing 290 feet behind the launch pad. So the launch pad is here, it launched the firework up and it explodes, and you are at 621 air distance from the firework when it explodes. So there's a couple things you're looking for. The angle of elevation for you to see the firework is 40 degrees, and from the launch pad it is 65 degrees. So to the nearest foot, what is the horizontal distance from the launch pad to the ignition point? So that's just where it explodes here in the picture. And so if you want to find the horizontal distance, that's going to be from here to here. That's how far over it moved from the initial point of launch, which forms a nice little right triangle. However, you're going to need some information on that if you're going to be able to find this missing side. So what you may want to go ahead and find is this piece here, and you can do that using the overall right triangle here, which has the 621 on it. In part E, when it says you're preparing to land an airplane, you're on a straight line approach path that forms a 31-degree vertical angle with the runway. So this being the runway here on the horizontal, the plane would follow a straight line path So that's going to be the hypotenuse of a right triangle from formed whenever you look at how high the airplane is straight up in the air, and then following its straight line path, which would go down the hypotenuse of this right triangle. Okay, so angle of depression on F, you've got a ship detecting a submarine at a distance of 1,300 meters and an angle of depression of 34 degrees. Remember that an angle of depression is always formed with respect to the horizontal in relation to the object, so you have the angle of 34 degrees being nested here, and that angle is going down to detect the submarine with its little periscope. And you're going to try and find how deep the submarine is, and so that's going to form your right triangle. Alright, on part G, you're designing a ramp where the horizontal distance is twice as long as the vertical rise. So the horizontal distance here is going to be 2 times as much as the vertical distance. Try and use the ratio of these sides, 2x to 1x, to help you determine the angle that the ramp is forming, and also whenever you have a 15-foot long ramp, and if you change that horizontal distance to 3 times as much as the vertical rise.